Argentum programs can be simple single-threaded apps with synchronous or asynchronous execution, or even complex multi-threaded ones with multiple stacks and global states. The latter needs advanced object lifetime management. So we'll start with a basic single-threaded model and expand to multithreading and async in the next chapters. Argentum uses the standard hardware stack. Functions call each other synchronously, with a single entry and exit point, so stack frames are strictly sequential and have nested lifetimes. Thus all locals are guaranteed to be disposed at function call's termination. In Argentum, variables of numeric, Boolean etc. data types are stored by value. In contrast, objects and arrays are allocated in the heap and referenced with pointers. There is a special temporary pointers that serve as local variables, function parameters, results and temporary values. They point from stack frames to the heap. In this example, we have local variable PTS pointing to the empty array instance, variable VB referencing an instance of class point, and a variable A of type pointer to an object which also references a point instance. Multiple temporary pointers can reference the same object, with no borrowing or ownership restrictions like in Rust. An object lives as long as at least one temporary pointer refers to it. It sounds as reference counting, though often the compiler can easily eliminate all reference counting code, like in this example. When the last temporary pointer goes out of scope, the object is immediately deleted on the same thread that created and used it, no garbage collection delays and uncertainty. This eliminates all need init-defer, finalizers, closable, finally, and other artificial constructs of other languages. Argentum objects can be copied with a built-in copy operation. It creates a new object with its own set of fields. It works with maximum memory and space efficiency. Copy operation is much more than just a byte-by-byte copy of an object. It supports object hierarchies, it backs const safety and multithreading. We'll revisit it later. Sometimes objects hold some external resources, fonts, sockets, file handles. Argentum allows defining after copy and destroy functions that automate resource lifetime handling. Here we copy a file object. Argentum copies all object fields and calls after copy file to handle platform resources. Here Argentum calls destroy file to free resources retained by the previous file instance. And here it calls destroy file for the current content of F and B variables. So all files will be properly closed no matter what. Temporary pointers are stack only. They can never be object fields and cannot be assigned to any object fields. They always point from the stack to the heap, preventing cycles and therefore memory leaks. In the next section, we'll discuss pointers between objects.